Hello students! So now that we've learned about what different transformations do, let's make sure we know the shapes of some basic functions so that we can then transform them. So a linear function, the parent function is what we think of as the initial shape. So for linear, that's y equals x, and of course that shape, let me just make a big set of axes over here. So the general shape of y equals x is a line with a slope of 1 that goes through the origin. All right, quadratic, the parent is y equals x squared. So that has an origin of 0, 0. I go over 1, up 1, over 1, up 1. It's symmetric. Over 2, up 4. And here's my shape. Whoa, try to make it symmetric. The basic cubic is x cubed, also goes through the origin, also goes through 1, 1, but then goes through 1, negative 1. And it looks something like this. Oops. The radical function, the parent version of that, is y equals root x. Again, through the origin, again through 1, 1, but now goes through the point 4, 2. So this one looks like this. Absolute value, let's go with pink. Guess what? It goes through the origin and has a slope of negative 1 for x less than 1 and a slope of positive 1 for x greater than 1. The exponential function, let's go with brown. That's, whoops, y equals a to the x. So this is going to have as its asymptote the x-axis. It's going to go through, instead of 1, 0, 0, I'm going to go through whatever my a value is. Oh, sorry, not my a value. I'm going to go through 1 because when x is 0, how can I get rid of just that dot? Yeah, when x is 0, a to the 0 is 1. So asymptote, and then I'm going to shoot on up. Logarithmic is the inverse. So I'm going to take this and reflect it over my line y equals x. So it's going to look like this. And now this is my point 1. So I'm also going to put this as log base a of x. And then my reciprocal function is 1 over x. Again, the x-axis is my asymptote, but the y-axis is also my asymptote. And I'll have the same thing on this side. So there are my basic parent functions that I will apply my transformations to.